This is a recording of a demo that I did as part of the ENSCI webinars on Quick Release 1 data that were held in April 2025. The demos that I did were specifically on the Euclid Data Explorer. So if you go to the IRSA main page and click on the Euclid icon, you get dropped into the mission page, which has a whole bunch of information about the telescope, the instruments, and documentation associated with this data release. I'm going to talk specifically about the Euclid Data Explorer here. When you first launch the tool, you're dropped into a Results tab. All of the searches that you do are going to drop their results into this Results tab. By default, you get an Images tab, an Inspect Objects tab, a Search by ID tab, and a Euclid Catalogs tab, which I'll go through in a minute. But over here, you can add additional tabs, remove tabs, and you can also have it be dark mode or light mode or whatever your system is currently doing. Let's start by going to an Images tab. For both the Images and the Inspect Object tabs, you get a HIPS image, which is an all-sky image. The very nature of a HIPS image is different than a FITS image. HIPS images are all-sky images, and they use adaptive resolution and a tiling scheme such that it can dynamically adapt to whatever view you have of the sky. It also tiles the sky, which makes it pretty easy to overlay, say, coverage. In other words, for example, in this case, the yellow is the planned Euclid observations. Now, it might be a little bit hard to tell if you don't know anything about what Euclid is planning to know what is on and what is off for the yellow footprints. If you go to the layers icon, you can change this so that it's filling up. So the yellow is the planned Euclid observations. So if you didn't know already, Euclid is not planning to observe either the galactic plane or the ecliptic plane. But that makes it hard to see through the yellow to see what the image underneath looks like. So that's why by default it's on outline. So the red footprints are the currently released data. You can click and drag this image and you can zoom. In order to pick a position, you can click, but you can also just type in a position. You can put in a polygon or a list of objects. You can also change exactly what kind of search you're doing. But for this, I'm just going to go ahead and go with where I clicked. So I've got a tab here in the Results tab that is Images because I did an image search. And it's giving me a list of one tile. And over here, it's got 8 images. That is how things work in the world of Euclid. It works by this tile ID. So this one row corresponds to this tile ID, and this tile has 8 different wavelengths. The top row here is the space-based data, 1 vis and 3 NISP. And then here along the bottom, we've got 4 DECAM image fragments. Now up here, you can see that not only am I in a cutouts tab, but I've got this icon here. It's telling you this is a cutout, and it's about 60 arc seconds. And if you click on it, you can see that icon means it's centered on the search target center. Let's put that away for the moment, and let's do an inspect object search. It's loading the same kind of interface as I did for images, and it remembers the position that I used. So I'm just going to go ahead and search. Okay, so it's come back with 14,000, 15,000 sources in this region. And it's overlaid them on the image here. But let's look and see. Here, we've got cutouts with this icon on 60 arc seconds. And here, it's changed, and it's clearly a different part of the sky. So if I click on this again, you can see now the cutout is centered on a table row position, not the search target center. I can change this. I can put in a different position. I can change the cutout size. I can also, if I want, get the whole image. I'm not going to do that though right now because the Euclid images are enormous and I don't want to wait for that image to download right now. But if I change the cutout settings here, when I hit Update Cutout, then we'll update the cutouts here to reflect the cutout settings that I changed. Now, it is a little bit disconcerting sometimes to see the sky jump like this. What is it doing? Well, let's go to the Coverage tab. Okay, that big orange polygon, that's the footprint of that tile. And the reason it's orange as opposed to pink, which is what that swatch is because it's the selected one and there's only one in the table. So that's why it's coming up as orange. So let's go back to the Objects tab. Now here it's got 15,000 sources. Rather than trying to render all 15,000 sources, it has shown them in these binned tiles. If I zoom in enough, it will show me all the individual sources. But if I'm zoomed out, then it's gonna, at a certain point, roll over to putting the catalog in these cells. If I wanna see the individual cells, I can just click on the cells and it will show me the sources from those. Or again, if I zoom in enough, it will render each source accordingly. But because I have this first source in the list here, and because the Cutouts tab is set to center on the source in the list, and that source is not in the center of the box, that's why it's jumping. That's why the cutouts seem to be jumping. So in order to not make it jump, if we go over here, back to the Images tab, that catalog that's overlaid is that object catalog. But they're all interlinked. So if you click on that source, so now that source is selected. If you go back over here, look, now I'm on page 49 of 146, and it's that row. So that source corresponds to this source in the image, which is close to the center of the requested tile. So that's why it's jumping. If you don't like the jumping, you can go over here and you can turn off pan by table row. That's what it's doing. It's jumping, it's changing the position of the cutout to reflect the object that you've selected in the table. You can also change that by saying, no, I really want the cutout to be the search target center rather than the table row position, or I would really like the cutout to be at a user entered position. And of course, you can also get the whole image if you want, but I don't recommend doing that because the Euclid images are really big. Okay, let's try another search. Let's get this tile ID and let's go to search by ID. I can do a search by IDs. So now tile ID is selected. I can get, for example, all of the objects associated with this tile ID, or I can get a list of images associated with this tile ID. Let's put in objects and that tile ID search. Okay, now it's come back with 113,000 sources from that tile. And you see how it's this turquoise color? That turquoise catalog is overlaid here. And you can change what color it is and what symbol size it is here. If we go back to the coverage map, you can see that the turquoise catalog covers the whole tile, whereas the original catalog we requested is here. Let's do something different. Let's go to the Euclid Catalogs tab. This looks intimidating, but it's really not too bad. What it's doing is it's actually pretty powerful. It's giving you access to all the Euclid catalogs. The first catalog that's here is the same catalog you get to when you do an inspect object search. So we've got a position in there. Let's go ahead and get just the small catalog. So yeah, so just a small search radius, only 9 sources. That's fine. And it's centered right there. If I zoom in, you can see it in that sort of that color. It's here. We can get rid of the big search. Let's get rid of that one. Okay, so it's that little tiny sort of periwinkle source list there. But let's go look at some of these other catalogs, like PhotoZ. Look, there's no RA index in there. There's 67 columns, and if I can sort this search in here, there's no column that has RA index in there. How do you use a catalog that doesn't have RA index? Let's go back to the results and look here. We've got object ID. Let's get that object ID. We can go over here to Euclid Catalogs. Spatial searches aren't going to work because there's no RA index, but an object ID search will. So I can put in the one object ID that I just copied and tell it to match to the object ID and search. Then I get the one line of that catalog. And if I go to details, this is a really long row. This is a vertical view of that long row. And moreover, where it can, it's got a description of what that field is. So if you're new at this and you're not yet familiar with this catalog, I am not, it will tell you where it can what that column is. So that's really useful when you're starting out. But do you really have to do individual sources one by one? Nope. You can load object IDs from a table. Now, I could go over here to that list of sources and save it and then upload it again, but the tool already has that loaded. So I can tell it, no, you want to use the one that's already loaded. And I want to use that search result because it's the one with 9 rows. Load the table, and I want to use the object ID from that uploaded table, match it against the object ID in this catalog, search. Oh, didn't work. Let's try that. Let's make sure object ID is set. Search. Those are the matches to that. So that's how you use a catalog that doesn't have RA and DEC, is you match by the object ID. If you're doing this on your own and you want to upload your own list of object IDs, keep in mind that this object ID is a long integer. And at the end of the day, computers are excruciatingly stupid. So it needs to match exactly. You can't match a string to a long because the computer thinks it's not the same thing. So you need to make sure that you're matching apples and apples. Now, in order to download data, if you go to the Images tab, click here, Generate Download Script, what this is doing is it's going to give you a list of curl commands that will pull the individual files from the copy that's here at IRSA. Now, as Vandana was saying in her talk a few minutes ago, one of the things that we recommend that you do is not necessarily pull the copies of files from IRSA, but you should do a little bit of modification to pull from the cloud because we think it will go faster for you, especially if you're pulling whole Euclid images. You can also get a wget script if you don't like curl. You can also just get the plain text URLs. And you can choose exactly what products you want to download. This is the file name that it's going to put all those commands into. You can save it to your local disk or the IRSA workspace. And you control where on the local disk this goes. Maybe your downloads folder, you should check. So the same thing works for the other tabs as well. You can select a role, generate download script, and you get the same choices. If you just want to save the catalog though, if you click on the diskette icon, it will save it as an IPAC table file or any of a variety of formats, and then you can save it that way. Note that if you're looking at cutouts here, then when you go to generate download script, it's going to give you the cutouts. If you want the full images, you got to change this to be full images and then download script, and then you'll get the full images. If you have a large request, when you go to generate download script, it may put it in the background monitor, in which case it will show up here, and then you can watch it complete, or you can actually enter your email and it will let you know when it's done. There's online help with more details. I didn't even begin to go into all the capabilities that this tool has when it comes to dealing with the images or dealing with the tables. There's lots and lots of things that this tool can do. There's plots that you can make and all sorts of other capabilities. So I encourage you to poke around, have fun, play around with the data a little bit before you start launching into making detailed Python scripts, because I always find it useful to see what the data look like, to see what data are available before I start writing lots and lots of scripts to go and pull data.